If two shapes are similar, how can you use information about the shapes to find the unknown side lengths? So here we are given two triangles, and we know that they are similar because it tells us that. So if we first look at triangle ABC, you'll notice that we have one angle measure, and we're missing the measures for angle B and C. So I'm going to use triangle PQR, the larger triangle, to help us figure out the missing angle measures. And I notice here that angle A and angle P are corresponding angles because they also have the same angle measure, 45 degrees. Now in the larger triangle, I see angle Q also has a measure of 100 degrees. So the corresponding angle for Q is B. And you'll notice here that they both have two arcs, which also tells us that their angle measures are the same. So the angle measure for B is also 100 degrees. To find the third angle, we need to remember that the sum of the interior angles of any triangle always add up to 180 degrees. So if I use that information, I can subtract the known angles here, 45 and 100 add up to 145. I can subtract 145 from 180 to find the missing angle measure of 35 degrees. So angle C is 35 degrees, which also means that the corresponding angle R is also 35 degrees. So now we're ready to look at the side lengths. You notice in the smaller triangle, we know all of the side lengths. And in the larger triangle, we are missing two of the side lengths. The first thing that I want to do is identify corresponding sides. So I'm going to highlight the corresponding sides here. The first one in green, so side BC and side QR here are in the same relative position in this triangle. They are corresponding. You will notice here that they don't have to be equal. They are corresponding side lengths. Next, I'm going to look at AC and PR. These are also corresponding side lengths. And finally, in yellow here, AB and PQ are corresponding side lengths. So to first find the missing side length PR in blue in the larger triangle, I'm going to use equivalent ratios to do that. And there are actually two methods to do this. The first one is we are going to create equivalent ratios using the corresponding sides. So in this case, I am actually going to use the green side here, and I'm going to start with the larger triangle, the length of 12 that I know, and the corresponding side length of the smaller triangle is 6. So I'm going to write the ratio 12 over 6, or 12 to 6. Then I am going to look at the blue sides here because I'm trying to find PR. PR comes from the larger triangle, so that goes in the numerator. And then the corresponding side length of the smaller triangle has a length of 7. So I can set those two ratios equal to each other. And I'm noticing that the numerator, or the top, is twice the denominator. So that helps me think about what is the value here, or the length of PR. What is 7 times 2? We can see here that PR has a length of 14. So you might be wondering if it is important to always start with the larger figure. I'm going to show you here that we can actually switch the order. The order doesn't matter as long as we are consistent with each ratio. So in this case, if I started with the smaller triangle, length BC, this green one, had a length of 6, and its corresponding side a length of 12 from the larger triangle, I would set up my second ratio, starting again with the smaller triangle, that length of 7 over the missing side length, or the one we're trying to figure out, PR, in the denominator. And you'll notice here now that the numerator is half of the denominator. So 7 is half of 14. You'll see here that I get the same answer. You'll also notice here that using corresponding sides, we are really just calculating the scale factor. So if you look at the very first ratio here, 12 over 6, 12 divided by 6 is equal to 2. 2 is the scale factor when we are going from the smaller rectangle to the larger rectangle. Remember, a scale factor greater than 1 tells us that we are enlarging the original figure. If you look at the second ratio, 6 over 12 or 6/12, that simplifies to 1/2. That is also a scale factor here when we are going from the larger rectangle to the smaller rectangle. So remember, a scale factor of less than 1 tells us that we are shrinking our original figure. A second way to figure out a missing side length is still using equivalent ratios, but this time using a ratio of adjacent sides. Remember, adjacent means next to. So first what we're going to do is we're going to look at the smaller triangle here, and we are going to try to find the missing side length here, corresponding side length in yellow. So I'm going to set up a ratio here. You can pick any of the two sides that are next to each other. I'm going to use 6 over 4. And I'm going to set that equal to the ratio from the larger triangle using the same corresponding side lengths here, but within the larger triangle. So I'm looking at the green side here, 12 over the missing side length here, PQ. So this is another method to actually find a missing side length here. So you'll see here that 6/4, if I think about doubling this, then I can multiply the numerator and the denominator by 2. 6/4 is equivalent to 12/8. So my length here of PQ is equal to 8. Now this particular method using adjacent sides within a figure does not tell you anything about the scale factor or how much our original is going to grow or shrink. But it does tell us, help us find the missing side lengths, and it can also help us determine if figures are similar. So either one of these methods will work to find missing side lengths. Sometimes one turns out to be a little bit nicer depending on the numbers and the information given, but you can choose to use either method.